So I have been a little bold to say that quantum biology may be the future of life sciences. Many of you may be wondering why a physicist is going to make such a prediction, because physicists are very bold. You must have seen from the talk of Professor Kaushik how we deal with things very small to very big and make extrapolations over wide ranges and sometimes claim things which probably takes 50 years to verify and may also cost, as you will see in my explanation, an enormous amount of money to verify. Now, this is my outline, doesn't matter. Now, the biologist's view of consciousness, let me start with, is the famous, the famous book of Francis Crick, The Astonishing Hypothesis, spells it out. Your joys, your sorrows, your memories, and your ambitions, your sense of personal identity, your free will, are all in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. That's what is given below. Now, supposing you look at a rose, then let us analyze what is happening in the brain and what is happening in the so-called mind. Now, in the brain, what you see is formation of the image of the flower on the retina, then activation of rods and cones in the retina at various layers, generation of action potentials and electrical pulses, transmission of pulses through axons in neurons, happenings in synapses and dendrites, release of neurotransmitter chemicals at various locations, and activation of cortices. This is the way the neuroscientist looks at the whole thing. But what is actually happening in the brain is distinctive perception of the recognition of the rose, evokes sense of beauty, smell, the awareness of the I'm finding it a little difficult to read that. The awareness and recognition, color of the flower, the softness and smoothness of the petals on touching the same, appreciation of symmetry, beauty of the flower, and then various types of emotions are also released, because you may think of the first place where you saw the flower garden with roses, or you may think of the girl who was wearing a beautiful rose flower, whatever it is. All this comes in your mind. It doesn't happen in the brain, at least the way we understand it. Now, when you analyze it, there are several barriers. The barrier problem is how to connect or bridge the gap in understanding of different categories of experience. You see, the left-hand side, that is the brain side, is one, and the right-hand side, the mind side, is another. These are entirely different categories of our experience. The so-called, pulses, electrical pulses, and things like that, we learn in the laboratory what they are. There's one kind of experience. On the other side, we know by personal experience what beauty is, what color is, what, etc. The neuronal electrical pulses, neurotransmitter chemicals, the oscillations, one kind of laboratory experience, which can be subjected to measurement. The advantage there is you can do some kind of measurement in those things. That has to be bridged with perception, sensation, feelings, emotions, thoughts, memories, an entirely different kind of experience. And of course, there is an interaction between the two because of motor actions. You find mind directs the body for the various movements and things like that. There is also the problem, so-called binding problem for the neuroscientists. That is, in the information goes to different parts of the different cortices, and also to different cortices altogether. So how do you bind all the information that is available to you? That's another big problem, which so far they have not been able to understand. How, in what way the memories are stored? Because for interpretation, you need the memories simultaneously that has to come. Otherwise, you won't get recognition, you won't remember the person, whatever it is. Kind of. Is there or is there not a central agency? In the old days, it was called the homunculus. This idea had been given up, but in the latest book of Koch, which I read recently, he again brings back. But this homunculus is a place where all the information comes in, and then he says it's a material body and not something outside matter. Similar analogous problems had arisen. This is the point which I want to make in the field of physics over the past several centuries. This kind of barrier problems may appear very difficult to reconcile with at the present time in the area of life sciences, but we have had this experience all the time as physicists. You take, for example, the gravitational problem. Newton said there is a gravitational force. He did not know how the gravitational force arises and how the gravitational force acts from the sun to the earth. Absolutely. When somebody asked him that, he says, God only knows. He had no idea of how the gravitational force was produced, and he had no idea. And that thing persisted for almost 400 years. That ignorance, I would say, persisted for almost 400 years. Then we also are familiar with electricity and magnetism. Electricity is one kind of experience. You know the shocks that we get when you touch an electrified object. And magnetism is an entirely different thing. But very soon we realize that the two are somehow related. That relation which Maxwell used some empirical results of Faraday and others to formulate some equations, and then predicted electromagnetic waves and found somehow the wave had the same velocity as that of light, and said that light also is an electromagnetic wave. There was nothing to establish that light is really an electromagnetic wave at that point of time. It was a bold gesture, and then it was later on very well established. And of course, Newton had all the time talked about the particulate aspect of light, and later on, as you all know, a lot of experiments were there which proved by Fresnel and others that light is a wave. So this, how can the same entity be a wave in one instance and a particle in another instance? This wave-particle duality has been there for the last almost 200 years or so, but that is now reconciled. By what I am trying to say is all these have been reconciled in some way. Then, of course, came the mystery of discrete spectral lines, and that led to the quantum states which Bohr brought in, the Bohr's quantum theory of the atom, and then the discrete spectral lines being due to energy states. But again, a pure assumption. There is no reason why the various energy states should be quantized. Only if they are quantized can I explain the discrete spectral lines. You can see the way the physicists have been asserting things before and then trying to justify it on the basis. What the physicists had, which I feel the neuroscientists don't have, is the advantage of mathematics. See, what they did was most of these were formulated in the form of equations, and the equations helped them to predict, and the predictions were verified. And that was taken to be a very good indication about the correctness of the theory. And it proved, nothing like success. Then also, we have the problems of velocity of light being independent of the motion of the observer or the source. This was completely contradictory even today for our experience, because we all know that two velocities should always add or subtract and cannot be independent. And that is what happened in the case of light. This is another barrier. Basically, how can it happen? Till Einstein came and resolved the whole thing. Then there is also rate of flow of time, and then length of space, you see, varying with the velocity of the reference frame, basically. These are all basic experimental facts, some of them predicted and later on verified, which, you see, were really problems in terms of understanding on the basis of common sense, on the basis of what we call classical physics, later on, which were all removed in a certain way by the advent of relativity physics and then quantum mechanics. Of course, the other thing was, I'll show that a little later. See, a cosmic ray particle would come and suddenly produce 100 particles. From where? Where were those particles? It would just come into the air and produce 100 types of, different types of particles, protons, neutrons, nucleons, baryons, and mesons, etc. Where were they? The production mechanism of such particles was another big mystery, how it was happening. All that we know is energy deposition was there. But where were these particles? And I think I have a... Yeah, you see here, for example, here you can see one particle coming, and then a large number of secondary particles are produced in a nuclear emulsion stack. Similarly, people saw a gamma ray would come, scatter an electron out, and suddenly a pair of positrons and electrons would turn up. Where were these particles? See, this creation of pairs, production of particles, etc., these things, a lot of experiments were done. It took a long time to understand how exactly they came into existence, where were they before they were seen, basically. It's a question that has bothered all of us, but finally the answer came how? The answer came from the fact that all these are in the form of waves in what we call the quantum mechanical vacuum, which is the basis of what we, as Professor Bhowmick explained, that is the basis of everything. All these waves are hidden in the what we call vacuum today. The quantum mechanical vacuum is there. What all that happens is energy is deposited, then you can interact. That interaction, when the energy is deposited there, the collision gives rise to an exceedingly high source of energy there, and that energy releases all the particles which are hidden in the form of waves in the quantum mechanical vacuum. You have got to have a wave for every particle that is produced, and later on it turned out not only one particle, you have got to have particle and antiparticle should also be produced because of certain conservation laws and things like that. That is one of the secrets that came out of the fact that vacuum is the source for everything that is created. And that is the beauty of quantum mechanics also. It is no classical process can give you, can result in the creation of anything new. It is only a quantum process that can give rise to the creation of something new. Wherever, whether it is in physics or in wherever you go, it has to be a quantum process alone that can create something new. Not only that, you see, quantum mechanics brought in another very surprising feature, that is, you take a proton, and a proton cannot, supposing it is at rest or it is just moving. According to quantum mechanics, because of the properties of the vacuum that is there. See, the proton will not remain a proton. It can become a pi plus and a neutron, and this neutron can become a proton and a pi minus, and that pi minus can react with the neutron and become an antiproton. You see, this kind of thing, according to theory, is going on continuously, but all this is, these are called virtual particles. All this is happening in such exceedingly short intervals of time that you cannot record them with it. So what I'm trying to emphasize is there are many, many processes that go on in the vacuum that cannot be recorded, but have to take place for us to understand many aspects of physics today. Because these are all established only by the predictions and what can happen later because of those predictions. This, for example, is the decay of a particle. A pi plus comes, decays into a mu meson, and then decays into an electron. Now, why should a pi meson, where was the mu meson? Where was the electron when it decays? It's again a very complicated thing. For this, you have got to bring in a weak force, production of intermediate vector bosons, and the intermediate vector bosons then giving rise to the mu mesons and things like that. So every process that we see in particle physics is a very complicated one. You see, we don't normally worry about it because nobody worries about pi mu e, that there is so much of intricacy going on inside to understand the decay process. So my contention is that it is not correct on our part to think that we will solve the problem of consciousness just by studying the neuronal pulses and then, the kind of neurotransmitter chemical. It is not probably at that level. What nature is telling us is there is a lot more secret things going on, secret processes, physical processes going on, and in exceedingly small intervals of space and time. And to be able to really realize that, you have to do very, very intricate experiments. Now, you see, for example, today, a $10 billion accelerator has been built in Geneva. What for? To detect the Higgs boson. What is the reason for that? That the Higgs boson is one that can give mass to all particles. If the Higgs boson is not there, corresponding the Higgs field is not there, you can't get mass to any of the particles that we know of. You see, for example, if you ask me, where did I get my weight? Say 70 kilos. You say, add the atoms on in your body. Yes, I add the atoms. Then you go further and say, the atoms, they get their mass from the protons and neutrons. Okay. Then you say, protons and neutrons are made of quarks, and you add the masses of quarks. There itself you get into trouble, because the quark masses are exceedingly small compared to the nucleon mass. So what is happening there? Something very intricate, as Professor Kaushik was explaining. Inside, the forces are such that the gluons that are there are traveling with enormous amount of velocity. It is the kinetic energy of the gluons that is responsible for much of the mass of the proton, basically. Whereas quark masses are small. But even then the quark has to get a mass. That quark or the electron or any particle, if it has to get mass, according to current ideas of quantum theory, it has to interact with a particle called the Higgs boson. And the Higgs boson, we don't know, according to theory, what mass it is, but today they are doing this experiment in CERN to see whether it is anywhere in the region of 1500 GeV kind of region. Now, the point is, this particle has enormous other properties. This field has enormous other properties. Professor Kaushik talked about that the universe is not only expanding, but is also accelerating. That means there is something, as Einstein said right in the beginning, there is a negative gravitational effect in the universe. And that negative gravitational effect comes into operation only at long distances because it is comparatively weaker compared to the normal attractive force of gravitation. So gravitation has got two aspects. One is the attractive force and the other is the repulsive force. And that repulsive force of gravitation comes through the Higgs field. The Higgs field is responsible for it. Not only that, Professor Bhaumik showed the three different types of forces, but they were all together at some point of time, long time back. How did they become separate? It's again the Higgs boson's interaction that was responsible for changing one particular type of force into four different types of forces: gravitational force, and then the electromagnetic force. And out of these two had to be massive because the range was exceedingly small. So the point is, what want to convey to you is that the neuroscientists, while they have done enormously fantastic work in terms of delineating all the detailed things that are going on in the neurons and in the axons and various, inside the body, and various theories have been proposed as to what normal quantum mechanics can be doing, that which you also heard a little bit today from Habermas, etc. There could be many more processes that are going on inside. There can be many more types of accelerating, there are many more types of forces hidden in the vacuum. You see, the way vacuum is conceived today, there is no limit to, they have not been able to set a limit to say only this number of fields, only this number of forces. There's nothing like that in the theory. So you can go on adding. Every time we discover a new particle, literally we have to add one more kind of field to the vacuum to be able to understand that particle. We also say that antiparticle must be there and so on. So according to physics today, the way I have understood it, that there is plenty of scope for many new things to be happening in trying to figure out what is happening by way of consciousness. And this is a new environment. You see, the brain and all the various network of the neurons, etc., is an entirely new kind of network that is there, in which detailed investigations have to be done. One doesn't know what kind of investigations need to be done, but I think that will be the 21st century experimental research that has to be done as a cooperation between physicists. And, see, the advantage that physicists had in terms of mathematics, unfortunately, is still now not very much there for neuroscientists. But maybe it will come, because as you can saw in this morning's talks, there are people attempting to bring in, mathematical equations into the deeper considerations of explanation of some of the things that are going on in the brain and the thing. So, I'll see where I think I will stop here, because I would like to spend the next half an hour to 45 minutes to answer questions for all of us, and then a proper discussion. Thank you.
Should I go? Taposh Datta. I've been a silicon designer for many years, and right now in an international production of a film on Vivekananda. My current excitement also stems from the fact that I've been reading a book on the holographic universe by Michael Talbot, and I want to see how much of knowledge from you about how much of the David Bohm's holographic universe theories and Pribram's holographic brain theories fit in or are relevant to what you're saying today, or the emerging theories today.
I think very interesting questions. Hologram, as you know, is a very particular way of storing information. If you make a hologram of yourself, a picture, you can destroy it, or rather break it down into 10 pieces.
And
each one will have the same information as the original you, except that the resolution will be a little lower. So what it means again is that the source is really present everywhere, and also, as I was saying, that it's probably coherent in a way that the idea of universe that we are seeing through the quantum field theory today, that not only in each element of space-time, the actions are all coherent, but they're also coherent with respect to other space-times of the whole entire universe. So once, as if the whole universe as one entity, from Planck's dimension to our dimension and across the universe, is fluctuating in emission and coherence. So almost like the information in one place is exactly the same as the other place. So the universe is acting like a hologram. So I think there's a very good reason to believe in the holographic description of Bohm and Pribram.
Thank you. One quick question to Dr. Kaushik is that if you consider the alternate cosmological model of the cyclic model by Steinhardt and Turok, which does not have inflation, then does some of the things about entropy you're saying still hold true?
See, my basic point was the need for a source of energy at high temperature like a star that is needed to drive order in this universe. Locally, you can drive order by working a Carnot engine between the high temperature and the low temperature. That work will you can use it to drive order. And in terms of cosmological considerations, I prefer the Occam's razor. You see, this picture that's currently what is called as the standard model of cosmology has a minimal set of parameters, and these other models have additional parameters. But we have only one universe. But at this moment, there is no compelling reason to give up this and go to that. It's a viable alternative, but we don't know how to distinguish by observations between them. I think earlier, the speaker who is just sitting ahead of you made the point. If you have a theory, you should have a way of testing it. Right now, we don't know how to test these theories.
Okay. I have one comment and question to Dr. Bhowmik, and then one comment to Dr. Kaushik. So first to Dr. Bhowmik. In 1932, famous biologist J.B.S. Holden, he published a paper in the first volume of British Journal of Philosophy, where he told that hydrogen and oxygen, this capacity of combination, is a kind of consciousness. But the discovery of Pauli exclusion principles changed our way of looking things. And famous biophysicist, American biophysicist, Harold Morowitz, he said, this is the most esoteric principle, might be the basis of Pauli exclusion principle is related with kind of consciousness. This is comment, and question is that you are speculating that vacuum might be aware. Aware of what? Is there any other thing other than vacuum or self-aware? And now to Dr. Kaushik, you are saying that entropy, especially Shannon information, Shannon entropy. 40 years before, from Berkeley, one book has been published, very famous biophysicist, saying that Shannon information theory is not adequate for description of living organisms. But if you consider Fisher information with Bayesian prior, that might be the proper way to handling the situations. Okay.
To explain how the vacuum has awareness, I think I'd like to bring your attention to the principle of complementarity in quantum physics, where two complementary aspects can exist simultaneously without breaking down. Like, for instance, the wave particle nature of a quantum entity. It can be a wave. It is a wave. It is a particle. We can call it a wavicle, but they cannot be separated, inseparable. So it's like the position and momentum, as you know, in Heisenberg's theory. So what I was suggesting that the association of awareness, how is it going to be in that vacuum? Well, we have the physical reality of the quantum fields, but what keeps their fidelity the same, exactly the same, since the beginning of time, is something that awareness or self-organization, self-interaction, and which is the hallmark of, which is the self-awareness, which is the hallmark of, self-referral, which is the hallmark of awareness. So awareness and the fields are inseparable and properties of the same system, and that's the way I look at it. Do I answer your question?
No, because its story is not finished. Because nowadays neuroscientists, they propose that the entities which can move, who had movements, they have the awareness. That's why they think plants don't have awareness. So in case of vacuum, where they move?
Well, the fields are moving.
Inside the system.
Inside the vacuum system, you mean?
Yes.
Well, the quantum fields are in the vacuum. They're part of they're part of space, and they're fluctuating. Yeah. But what's keeping their fidelity together for all times in a universal scale is something what we're.
Thank
you. Max Bellman's Goldsmiths, University of London. I have a question for all three of you, really, and I think it's a question for the whole day, which, for me, has conflated two kinds of question throughout the whole day. One is the issue of what are the conditions for the emergence of consciousness or for its existence, full stop, which haven't, I don't think, been clearly separated from the conditions for the evolution of consciousness once it emerged. And so throughout the whole day, we've had many different theories about the point at which consciousness first emerged. Perhaps the most basic is the one that you've just mentioned, which is that it exists in the background field. Others have said it only exists with cellular life. Others, when brains came into being, and so on. Now, I find it very easy to grasp the idea that as matter becomes more complicated and if there is associated consciousness with that matter, then that consciousness in turn will become more complicated simply by virtue of the association of consciousness with certain material forms. But the really deep question is, why should consciousness be there at all? Now, that brings in the second confound, as in my own understanding anyway, which is the confound of what it is like to function, or how something, rather, what are the properties which explain how something functions, and what is it like to be that something which is functioning in that particular sort of way. So to take, for example, your last example of self-referentiality, you could argue that simply having self-referential nature in a system shouldn't be enough to make the difference between having the light of consciousness being off and being on, because a simple feedback loop, for example, has self-referentiality. And so in the end, you're back to perhaps having to make a choice between what you might call the continuity theory, which says, well, maybe the question of when did consciousness emerge is rather like the question of when did mass emerge, or why is there consciousness is like the question of why should there be mass. And if you say it's that sort of basic question, then you have to say, well, it's a fundamental property of the universe, and the evolution of the material universe by way of coevolution also tells you about the way of consciousness. Or you make the other choice, which is very common in current cognitive psychology and current neuroscience, which says for eons there was no consciousness in the universe, but at a certain point it switched on, and then you have to explain why it was that particular switch which switched it on. And I would be very interested in your three views about those problems.
I think you have asked a number of questions that probably would take a bit of time to answer all of them. I'll try to attempt to answer the last one first, I guess. I'm forgetting, what was the last question? Yeah, right, yeah. As I said, there's quite a few questions actually. To begin with, as you said, sorry. Can you ask one by one?
No, I'd be very interested in each of your views about whether you are committed to consciousness in a sense being as
has been there from the very beginning. And as I was explaining before, that in the form, perhaps, as a self-referential system, to keep the fidelity of the fields, constantly changing field, because quantum fields are fluctuating so fast, we cannot even, our brain cannot even respond to it. But it can tap into, our brain can tap into, when the wave function global coherence in the brain collapses, it commandeers that what Hameroff has called proto-consciousness inherent in the universe, which I believe can be in the form of a self-referential system, which can be described mathematically with the non-abelian theories, non-commutative mathematics. And so, to begin with, consciousness was there from the very beginning, and the father of quantum physics, Max Planck, said, I believe consciousness is primary and matter is a derivative of consciousness. And there is good reasons to believe in that, because at the beginning, as you know, the total energy of the universe is zero. And because it started as zero, because we are all made of positive energy, but at the same time there is an equal amount of negative gravitational energy due to self-interaction or gravitational attraction, of mutual gravitational attraction of all particles. So the total energy of the universe is zero. And what created it? Well, the quantum fields really, when they came in, space, time, and quantum field came together, creating energy as well as the lack of energy, which is negative energy, so to speak. And it remained that way. So, I believe it is consciousness that is involved with these quantum fields that is keeping this viability of the space-time and field together. So, in that sense, like if you ever read Indian philosophy, that our source, Brahma, is not only the creator, but it also the ingredient of creation. Like a person creates a clay pot. Brahma is the creator of, as well as the providing the element of creation. So in that sense, we are seeing the parallel here in quantum physics, that the awareness aspect that is associated with the quantum fields is not only controlling or rather keeping the probability of space itself with the metric field, as well as it is sustaining all the properties of the basic fundamental properties, but also giving the ingredients, creating the ingredients by creating the energy. And so in that sense, I would say consciousness is primary, as eloquently said by Max Planck. The other aspect that you mentioned, that through evolution, at what point the awareness become consciousness? Well, I guess as evolution goes on, software, the neural circuitry that builds up around us, becomes gradually more and more intricate up to what we are seeing by all, through all the speakers. So that we are allowed to experience as much as nature has given us the capacity. Who says that evolution has stopped here? And in fact, I hope that in future, as Sri Aurobindo has said, that the next stage of evolution will be here in mind, and the aspect of so-called mystic experience, which is actually a misnomer probably, because it's described by the experience in the same way. That would be a very clear, focused, blissful state that many people have talked about today, would be the next stage of evolution, and that is. So I believe that evolution hasn't stopped, and we will be evolving towards that direction. And so as nature allows us to understand more, we will do that. But I think some of the thing that has really has been an enigma to many physicists. Einstein, for example, what did he say? That the most incomprehensible thing in the universe is that it is comprehensible. And Penrose says that a similar way, that why is it that our brain is able to understand how the universe started, how it evolved, how we came about. If nature didn't want us to understand, we wouldn't understand that. And this is why John Wheeler said that it is incontrovertible that a conscious observer is involved in genesis. Consciousness is involved in genesis. Because if nature didn't, and that's why we know this so-called anthropic principle is becoming more, at least for this universe. We don't know about other universes, but at least for this universe, looks like when the universe started, it was so small that quantum mechanically all kinds of possibilities were there, and it could have evolved many other ways. So you have to factor in the fact that eventually consciousness would evolve to observe, and that was the initial condition for beginning of the universe. And in fact, again, John Wheeler said that. Sorry.
Exactly, John Wheeler is.
Yeah, that with the delayed choice experiment, that what we observe today actually could affect what has happened in the past. The fact that we have emerged with the conscious being was something. Was a necessary condition for beginning the universe. And Fabian Dyson also says, in a sense, the universe knew that we were coming. So I believe I've answered some of your question. If I missed any?
No, thank you.
Thank you very much.
I think we'll go that side, come back here. Shobhini?
Yeah. I take the point, I ask the questions one by one. First is regarding the mathematics and neuroscience. I do agree that we have missed quite a bit of mathematics. One reason could be because neuroscience is a composite discipline, and all people may not be having the aptitude for mathematics or the courage for mathematics. More likely the courage, I think. But a more serious question I wanted to ask is, the brain is an open system. It's interacting constantly and changing as a result of the environment. We see it at a micro scale, we see it at a macro scale. So we see it at a scale where, while I'm recording the EEG or when I'm doing an fMRI experiment, depending on the task, practice with the task, the activations change, the EEG records change. At a clinical level, as I am giving a cognitive retraining or a counseling, the patient's behavior keeps changing. So across time scales, we see the change, and we saw in today morning's presentations how at a micro levels also these changes occur. And these changes are dependent on the environmental changes. Are there mathematics to account for this level of interaction and dynamicity? Is there mathematics developed which will account for this level of dynamicity and interaction between two changing systems?
I don't know whether it has been developed or not, but what I meant to say was two things. Firstly, regarding micro, you see, what I am talking about is micro things happening. See, in physics, what we are now doing are things in spatial intervals and time intervals of 10 to the power of minus 18 to minus 23 seconds, which is orders of magnitude different, but many significant things are happening there. For example, I showed the decay of a particle. You see, what happens inside the decay of each is something that happens in a time interval of less than 10 to the power of minus 23 seconds. When all those particles are produced, it is something that happens in a spatial interval less than 10 to the power of minus 15 centimeters, and then 10 to the power of minus 23 seconds, but you see the effect of that. So all I tried to convey was that many things are happening in exceedingly small intervals of space and time, which is not available to us unless we make special instrumentation and special efforts to look at them or predict what can be expected and then look for them.
The second, sir, is in terms of consciousness itself. I think the whole of today, we have been very implicitly defining consciousness as awareness. I don't know whether I am wrong. Consciousness as creation, as awareness, as change, and so on. Is it that when two opposites exist, consciousness emerges? Because if you observe whether in the physical realm that you described, the cosmological realm, or in the biological realm, there are two states which quickly flop from one to the other or change from one to the other. Is it that what we are today discussing, that aspect of consciousness, which is awareness or creation, does it require two opposite states to exist and one change from one state to the other? Would that be a simpler way of looking at it? Across scales, across matter, across living organisms, etc.
Yeah. See, awareness, I think, is one aspect of consciousness. Because consciousness, as you know, has much deeper levels, and subconscious, unconscious, and so many other levels are there. But I don't know whether awareness, the way normally we use the term, whether it has got levels. I'm not very sure.
What is the definition of consciousness that physicists are using? I was not clear about that. Because for me, a patient who is unconscious is also alive. He's in coma, but there are changes occurring in the body.
No,
the microtubules are still active. He is alive.
No.
In that sense, he's conscious, but he's not aware.
Conscious and not aware.
No.
Yeah, that's what I'm saying. This unconscious state is there. So there's no, you see, whereas you also have layers of consciousness. When we talk about the effects of meditation and things like that, you go to higher and higher levels of consciousness, basically.
Sir, I'm sorry if I'm repeating.
What
do physicists mean by consciousness?
Say, physicists, by and large, occasionally discuss consciousness. It is not their primary focus of thinking and interest. But when they try to do this, they are a little more abstract in their definition of consciousness as compared with the general discussions that have been going on here. For example, you asked, let me also, before I answer this question about specific to physics, let me talk about the earlier question you asked, which kind of may lead to give you a feeling as to how physicists think about things. Suppose you take an atom and you put it in a very tiny cavity. the presence of the atom changes the property of that cavity, in the sense that changes the vacuum inside that cavity. And the vacuum influences the atom, okay? So mathematics for dealing with it, physicists have, or mathematicians have developed, and physicists use it, and we can discuss and we can measure the spectral lines and get evidence for this interaction between that atom in the cavity and the vacuum in that cavity. So when physicists think of it, they are not thinking about broad things, but they abstract something. Physicists always make some very simple models. We heard a talk earlier, a model of two systems with very simple properties. So you can write down the mathematical equations and analyze them and try to compare that with some systems. The mathematical model, I mean, almost like the Platonic ideas that were there. There were some ideal solids and ideal things. You try to map that abstract world onto the real world, or real world onto that abstract world. And all that physicists are doing are create this abstract world of greater and greater complexity. And as that complexity grows, they are able to kind of see similar things in the external world that we all experience through this process of consciousness. So when physicists want to think of consciousness, they are thinking of systems which can have some of the attributes of consciousness that you measure on big systems, some attributes of consciousness at the level of the amoeba, or even some other things. Whereas they abstract all this and just a response to the environment. It need not be a very sophisticated response. For example, the example of a person who is unconscious, he is still responding to environment. If you cut him, he will bleed. Certainly. And there will be not only bleeding, I'm sure, neural signals will be transmitted. He doesn't jerk up and do this, but for a physicist, he doesn't care. The fact that some neural signals are there is all that he cares about. And he says this is what will happen. So in some sense, there is just like physicists tried to learn astronomy during the last century and do some science, I mean not many centuries actually, earlier on they were kind of same, and big astronomers came during the last century and physicists got into the game somewhat late, and we had to learn their language. Similarly, physicists may have to learn your language and try to put it in your language, and to some extent you have to also move a little bit towards us and try to see what we are trying to say.
I just add to a short comment is that awareness is common to all animate species, beginning from bacteria, paramecium, and so forth. But when you're able to cognize, when you are able to cognize, that's when we call that the entity has consciousness. And we humans have the, I guess, highest level of consciousness at this present, because we are the only one who are capable of abstraction. We are capable of mathematics. A cow cannot understand quantum mechanics, as far as we know, in a cognitive way. So when you are capable of abstraction and capable of understanding how the universe developed. In fact, even 20 years ago, if somebody said that I know how the universe started, how it developed, it would have been a hubris, pure hubris. But through the nature's own language, which is mathematics, we are able to understand how the universe started, how it evolved. And this abstraction is only capable in human brain, and that's where I believe we call human the best conscious entity in the universe today.
I need to add a comment a comment, if I may.
Yeah, please, very short.
Very short. Very recently, an experiment was done with pigeons who were taught to peck. There will be 1, 2, and 3, and 4 little grain-like objects. If it pecks them in sequence, the pigeon will get something to eat, some gratification. Later on, this trained pigeon was shown some marks, 7, 11, 18, and 27, or some number like that. It could peck those things in increasing order and still get its little bit of food, showing that this ordinal numbers, as we understand, perhaps the pigeon also understands the ordering of these things in a sequence. So it is true that the present-day experiments are at a very low level, and their levels of abstraction may be lower, but we cannot truly say they are non-absent in the face of these experiments.
Tomorrow's talks will tell us that animals do have quite a bit of cognitive capacities.
Yes, on this side.
Hello, good evening.
We are
Yes,
running
of
out of
course,
time.
yes. I've always, when by the time it comes to me, I have to be short. I'm a consciousness explorer, and I taught consciousness studies as a guest lecturer in California Institute in America. And I've always been questioning, why are we here? What is the purpose of the universe? And I've tried to understand it philosophically through Indian philosophy studies and Western philosophy. I very much enjoyed your presentations, Dr. Mani Bhaumik and Dr. Kaushik. I'm fascinated with Amit Goswami's ideas of self-aware universe and God is not dead. And I'm also aware of physicists and cosmologists looking into multiple universes. What is the purpose of consciousness? You have mentioned Sri Aurobindo, who said that everything was conscious, perhaps, out of which matter was formed, and perhaps it's evolving into some sort of a superior consciousness. What is your take on that? Last year, I got a full scholarship to study the evolution of consciousness at Schumacher College in Devon, England. And I met wonderful Cambridge-educated philosophers and physicists and biologists like Rupert Sheldrake and Stefan Harding and Steve Kelly. And we studied also that the Earth was conscious, perhaps. Perhaps scientists have missed that. Are we trying to go the way science has gone all along? And we know that classical physics and Newtonian Cartesian ideology no longer works at the quantum level, nor does it work on the cosmological level. Is there a way of getting out of the rut? Is it possible that other than the weak force, strong force, gravity, and electromagnetic, is there some other force? Have we created the concepts of dark energy and dark matter because we have tried to understand the universe the wrong way all along? Because we are basing the concept of everything is matter, everything is atomic. Let's go deep into the matter. Let's go deep into the quantum and try to understand reality. And looking within, what is within? I want to hear from you. Is that something that's a part that's conscious within us, in the neuroscientific brain? Or where is it?
I think the best way to put it probably is that your mind is not your brain.
That's right.
Because that's when you get into conflict. Mind is trying to put you on one way, and brain functions are trying to put you in
But there is a theory, that psychological theory, that mind is perhaps something that is utilizing the brain to understand and cognize the universe for survival, for procreation, for food, for analysis. So is everything conscious? Have things come from consciousness? How do you correlate and unify theories of consciousness? And what is looking within according to physics?
Well, that's why I said we have an inner self, which we call mind, and sometimes it gets out of tune from our neural activity, and usually that's when stress happens.
I'm not stressed.
Stress. That's when you get into stress, because you're getting conflicting stimulus in this technologically driven.
I watched a
global village.
program on BBC yesterday, last night. Just last one. Last
You
one.
see, there are still two more people.
Just last point, last
No, you can ask him per.
Okay. Okay. Okay.
Because there is also a poster session following this.
I see.
Non-reducible theory on which to base it. I want just one answer from each of the three. Can you name a non-reducible system in physics on which we could base consciousness? Non-reducible.
You see, my answer to that question is very simple. All physics that we have done so far, till recently, has been on the basis of reduction completely. We went on to reduce things to further and further and further, smaller and smaller dimensions, and then finally we ended up in a situation where we realized that we have to connect everything. So there has to be a non-reductive basis for everything that our reductive method has led us to.
Well, I believe the non-reducible is awareness, because you cannot reduce it further.
But how to find that basis in the physical systems? Either at the beginning of creation, which is where it should be if it's to be throughout creation, or in the human physiology, if we are to have a David Chalmers compatible theory for awareness, which is non-reducible, which is holistic, which has gestalt grasping.
It becomes one system. There is no difference between that. So in that sense, when we are being tuner of the universal consciousness or awareness, then really there is no difference. We're one and same system. That's the beauty of resonance. That's
the beauty of the mirror. The mirror that was in the talk at the first slide this afternoon, the mirror of the lake and the mountain.
Yes.
So you're saying that consciousness has to find the mirror within the human physiology which will act as a non-reductive system?
Aren't we mirrors? That universe made a mirror of itself to see itself. The awareness made a mirror to perceive awareness.
I would like to say that many of these questions, after tomorrow's and after tomorrow's discussions, will become much more clear or much more confusing.
Briefly, I endorse the first remarks that Professor Sreekantan made, that physics has been a reductionist science. I want to add, not only physics, our thinking has been influenced in a serious way with the reductionist approach, so that much of our questions and much of our answers and much of our understanding is somewhat reductionist in its basis. So, in some sense, so-called holistic ideas or holistic science has not yet emerged, and we don't have holistic theories in which we have developed the necessary language to communicate very effectively, especially a field as complex as consciousness.
Could I add one rider to that? I did a PhD in a particular area of physics called critical phenomena, and at a critical point there develops a coherence length which diverges. About a year ago, I suddenly realized I was looking at a holistic system because it was completely correlated across a critical region. And for that reason, I just wanted to bring this point up particularly.
Thank you very much.
Thank you very much for your answers. It was wonderful.
Yeah, last question.
It's just a small comment which I picked up from Dr. Shobni Roy's question, that are two systems going to make consciousness? So I was thinking about, unless you have a figure ground segregation, you have if everything is one, then you can't actually be aware of the other. So if there's a figure ground segregation, only then you are aware of something. So does it mean that at the point of symmetry breaking, that probably Bani Bhomik actually mentioned at the beginning of the universe, there's a symmetry breaking. The moment you have a symmetry breaking, you have at least one or two entities. Does consciousness come at that time?
Well, when the symmetry breaks, you have obviously more than one field.
That's right.
But as they do in mathematical lattice gauge theory, for example, they usually use coherent addition to describe the states. So there's a mathematics behind it which shows that there is a coherence between these fields. They're not just coming out and they're going on their own way. There is a coherence, and that is probably related to what we talked about self-interaction.
I'm sorry, I have to close the session now.